Thank you. Good morning, everyone. So glad to see you all here this morning. So we've been working through this idea of trying to meld together preservation and active research for about 12 months now in the collaboration we've had now. But really, I wanted to start with, why are we doing this in the first place? So giving some context from Notre Dame, where my home base is in the States. So when we were first approaching partners on campus related to getting excited about our institutional repository, and our institutional repository is actually fairly young still. It was new in 2013. One of the things that we went out and one of the key things we heard from our College of Science there was, well, we want to start archiving right now while we're working. I said, well, a repository isn't really built for that. It's built for long-term preservation. There's things like tape storage behind it where it's meant to be extremely stable, but it's not meant to be active research, active collaborating. So we really didn't have a way to deal with that. So then one of the things that was really very fortuitous is the OSF, the Open Science Framework, came along, where it was really looking to bridge this gap between the active research process and preservation. So we saw a huge opportunity, besides the fact that the folks at the Center for Open Science were really eager to work with us to solve this problem. And the Center for Open Science has the OSF as something, as a tool that really anyone can use. So it's not just about preservation, it's about a lot of different things. But one of the things we really approached in looking at the integration is how can we bridge the gap in terms of not just the active research cycle, but really to have more of a virtuous cycle where things are flowing throughout, where it's not just bringing research into preservation, but it's also starting to enable real reuse, real reproducibility, and the like. And we've had progressive stages in our work with the integration between Fedora and the OSF, where it has continually added more layers to get closer and closer to this process. One of the things I did want to point out here is at the very bottom is something where we have an integration that's with the Open Science Framework that's separate from the OSF integration, where it can go to National Data Services Workbench. And this is something that is in the States. The National Data Service is a similar thing to the Australian National Data Service, not as mature as the organization of ANDS, but it's kind of the same general idea. And the whole idea there is that you can actually take things that have been archived and rerun that code. So how can we continue to actually have preservation do the job it does well, and then other tools do their job as well as possible. So in terms of the key aspects of this, we really have been wanting to align our repository where it's not this process that's at the end, and really to have things flow very quickly, and reuse, et cetera. And one of the other important things that, or I guess really also useful, lucky things we had, there's within the Fedora community, as you know, there's a lot of people that are still running Fedora 3, some still running Fedora 4. We're in that Fedora 3 camp at Notre Dame, and we're right now starting to plan our migration to Fedora 4. But one of the nice things about having Hopkins and Notre Dame involved in this, we actually have support for both versions of Fedora. So it doesn't necessarily have to be a decision to push the migration now. One caveat there is that the next layer of enhanced integration is Fedora 4 only, and that is actually part of what's driving our migration, but we still have some support to have this active in the meantime. So there's my email and Twitter handle if you wanted to see any of that. So I will be talking kind of in Jeff Spee's stead, who's the Chief Technology Officer for the Center for Open Science, but kind of going into a little bit about the Open Science Framework and really what that brings in general. So one of the key aspects of the Open Science Framework is that it's focused on working to change the culture around how research happens, how science happens, et cetera. Really, there's a lot of incentives, culture incentives right now to get published as possible, as often and as often as possible. But really, and it's less about getting it absolutely right, but that's really what science should be about, right? So when you're looking at the overall workflow of what's happening, there's doing the actual, developing the idea, designing the study, analyzing data, writing the report, publishing, and you think about kind of where does preservation and curation typically fit in. It typically fits in at that stage, and really what is preservation all about? It's really about reproducibility. But again, if people are publishing as fast as they can, are they able to spend the time to capture everything that is actually going to enable this? And I think in many cases, there's lots of shortcuts happening, not necessarily because of ill will, but there's just, the cycle is just too accelerated, too compressed to really help researchers do this well. And the curation, reporting, those also fit in. But again, how do we get these things plugged into the actual workflow so it's not something off to the side? So we could actually talk about how it will make them more efficient to have things be higher quality. And we could actually demonstrate that things get published more often if data is more available, it's easier for other researchers to cite, et cetera. But really, it's in the end, it's about making it easy. And making it automatic is really the goal with this. And integrating with the workflow. So looking at this updated workflow, thinking about how we have this, it really is putting the preservation more in that collect, store data, analyze data stage to work on that. So going into the Open Science Framework more itself, so the URL for that is osf.io, and that is a publicly available, completely open, free service that is fully funded by the John Arnold Foundation, I think, is one of the primary funders. And so the Center for Open Science itself has a lot of solid backing that is not really dependent on this grant or that grant. They have really an extraordinary situation where they're able to provide this service without looking to do any cost recovery for things like storage, et cetera. And the tool itself, one of the things that I have always loved about the Open Science Framework is that it really doesn't work to try to replace or change the way that researchers are working. It looks to integrate with the way they're working. So it's all about making things easy to collaborate. Within the screen here, there's a basic project, and you can add contributors, and those contributors can really be anyone in the world. It doesn't really matter with that aspect. And there's also some obvious features like version control, et cetera. So a lot of these things are kind of the things that you would expect to be there. So some of the other features that are really critical within this, there's of course the privacy and permissions and all of this, and there are some analytics that can really drive a lot of the exposure to things. But one of the things that's really critical there is that's in bold is the project snapshotting. And that's something that is primarily done through the mechanism of registration within the Open Science Framework. And that is essentially a way to do a snapshot at any point in any time of any piece of a project, whether it be a sub-project, which is within the Open Science Framework, they refer to a sub-project as a component, but that's essentially what it is. And there's also the idea of forking, where you can actually take another project and do it very similar if you're familiar with the GitHub pattern for doing that. It's exactly the same way. It's forking a repo and then taking that, and you have permission to do what you want, but it still has the tie back to the original project. So the other really important aspect here is, I talked about how there's things in the OSF where it's really not trying to replace the way things are doing. So one of the important aspect is connecting to where the data actually is. So this is an example of how it can actually connect to a GitHub repo, and you can either edit those things directly through the Open Science Framework or work as you normally would, and those things will just be available within your project. So within the Open Science Framework, I again talked about how it's not really trying to replace what researchers are doing. These are some examples of some plugins that are there today where you can access data directly, whether it be in any of these cloud providers, Google Drive, Box, Amazon, et cetera. There are also similar things that we're talking about with Fedora hooking into Dataverse and Figshare. And then this is the list of other add-ons that are in progress. And you'll notice that Fedora is also in the list there, but there's other things like Evernote and the DMP tool, Vivo, OJS, et cetera. So it's really looking to fill in the spaces all across this workflow so that the OSF can just be sitting in the middle and really just trying to connect those things, but not really trying to get in the way. So thinking about Fedora, I will hand it over to David.
Yeah, thanks, Rick. I think from the Fedora perspective, we're really interested in this integration. And Rick alluded to this earlier, but in a lot of cases, institutions have Fedora repositories already, whether that's with Samvera or Islandora or a custom framework. The way things work right now is it's often research data sets, and the outputs of research are, they're not really captured until the end of the process, if at all. And getting them into the institutional repository can sometimes be difficult. But having Fedora as an add-on for OSF can make this process more automated, so that these kinds of outputs and data sets can be captured kind of throughout the research lifecycle rather than waiting until the very end, and in a seamless and automated way so that the researchers themselves really don't have to think about it, which I think is really valuable. Those of you that are maybe less familiar with Fedora, I'm not going to spend a lot of time on this. We did the repository rodeo, of course, at the beginning, and there's been a Fedora interest group track kind of throughout. So I won't spend a lot of time kind of talking about what Fedora is, but I think in terms of what it adds to OSF, a lot of this is just adding some repository sensibilities, particularly around preservation. A lot of these other add-ons that OSF supports, Box and Dropbox and Google Drive and things like that. They're all very useful, but they don't really have preservation sensibilities. And those of you that maybe caught Tom Kramer's talk yesterday on preservation, he mentioned a few things about some of the ways that Fedora supports preservation, not just as a standalone system, but enabling preservation activities and exporting to external preservation systems. And so in this context, by plugging Fedora into OSF, you can do things like export your entire OSF project into Fedora to then be able to do kind of preservation activities and things like that once it's in Fedora. Or going the other way, you can put things in Fedora and have them exposed through OSF. So there's a lot of value there, and I think from the Fedora perspective, it's a really good fit. Amongst other things, Fedora is really focused on integrations. It's really a piece of infrastructure. It's meant to work with a number of other systems and services through a very robust REST API, as well as a message-based architecture. And so I think this is just it's a really good fit for Fedora and something that we're quite interested in. So it's being added, as I mentioned, as kind of this a storage add-on, being able to push to Fedora or expose contents from Fedora, and really that's providing that level of preservation that just doesn't exist otherwise in a lot of the other components of the OSF. So that's sort of the value add there of having Fedora as a component. But I think there's other potential as well, because OSF is ultimately kind of a platform as a service. The view that you see when you go to osf.io is just one view. There are other views through preprints, registries, grant management, et cetera. And all of those are built on top of the same application framework, which provide these things like workflow and permissions, file storage, et cetera. And so you could imagine that Fedora could potentially kind of lay underneath that application framework and be exposed through a variety of different front-end views. And so that's sort of the direction that things are heading in. And just as an example here, you have things like OSF for institutions, where you can apply institutional branding to OSF, or a preprints version of OSF. And so there's a number of different views that we can use to expose OSF, and all of this can have a connection to Fedora at the back end to be able to provide that preservation sensibilities. But I want to keep things going here. If you want to get in touch, Jeff can't be here, but he contributed to all of the OSF slides. That's just his contact info as well as mine. But I think I'll pass to Saeed to just talk a bit about the Data Conservancy.
Good morning. The Data Conservancy was started through a grant from the U.S. National Science Foundation's DataNet program But we've taken it and moved it into this community-based effort that includes Notre Dame, DuraSpace, and Center for Open Science. It's really a set of components that are relevant in the context of the conversations we've been having this morning. It includes a specification for packaging, which builds on the Bagot specification, but also extends it by adding semantic information and support for linked data and multiple domain ontologies. A GUI-based tool that allows you to create these packages. So if you're, for example, a researcher out in the field and you're gathering the data, you can actually create those packages using this tool. We're also moving in the direction of creating a command line version of that tool so that you could create the tools in a batch process or a more automated way. A package ingest service that takes these packages, including the semantic information, and ingests them into archives. The implementation that we are supporting right now is Fedora 4. You could potentially archive those packages or deposit those packages into any archive, but the one that we are working with directly right now is Fedora 4. Once those packages are available in Fedora or within OSF, we have a linked data tool called RMAP, which is funded by the Sloan Foundation. And it's really an API, a set of APIs and a protocol for aggregations, or how you would describe these packages in a linked data format. This RMAP tool is also being integrated into OSF. So in essence, you could create your projects in OSF, or you could create these packages in Fedora, and you would be able to look at the connections through these linked data graphs. So as a researcher, I could see how my data are connected to publications, or how I'm connected to other researchers, and so on. We've already used RMAP with all of the article content from IEEE, so over 4 million articles, to generate these so-called DISCOs, or Distributed Information Scholarly Compound Object. We actually came up with DISCO first and then came up with that. But we've also used it for a project in the US through the Association of Research Library called SHARE, which is basically harvesting a lot of content from institutional repositories and other content providers. And we created a link network across the SHARE network. The final piece is the APIX, or API extensions to Fedora. You may have heard about that earlier as well. This is taking Fedora's core capabilities and extending them to support another set of capabilities or functionalities that have been defined through a lot of the research data management work we've been doing. The package ingest service, for example, is now an extension. So it is now one of the Fedora APIX extensions. So I think we have time to just show you a couple of video clips, because as David mentioned, there's two ways you can think about this. You can take projects from OSF and bring them into Fedora, or you can put your content into Fedora and expose it through OSF. And so these two videos basically demonstrate both these pathways. So if we could get the clips, that'd be great.
Support to our faculty by providing assurance of the durability and accessibilities of these resources over time through enhanced curation and stewardship. A stack of software works behind the scenes to enable preservation activities without disrupting the workflows of the OSF. A tool at JHU uses the OSF API to create an archival Bagot package from an OSF project containing OSF business objects represented as RDF resources and described in terms of a formal ontology. These archival packages are then deposited into a Fedora repository. Browsing Fedora's basic built-in user interface, we can explore the structure of OSF business objects as they're represented as RDF linked data. The properties and relationships that define the essential characteristics of OSF objects are translated from their original JSON representation and formalized using an RDF ontology. The structure of the OSF business objects in Fedora is particularly amenable to recording provenance and fixity-related metadata, such as checksums, links to the original sources, and more. This enables preservation-related workflows in the institutional Fedora repository, such as creating an audit trail of changes, fixity checking of datasets, archiving historical versions, etc. The takeaway is that the services in the repository stack have the information they need in order to perform their functions asynchronously behind the scenes and fulfill our institution's business needs.
We've used the packaging tool to create a package containing rich semantic metadata and have ingested the resources into Fedora as linked data. The package ingest service deposits each resource from the package as a resource in Fedora and maintains the links between resources, remapping package URIs to Fedora URIs. APIX allowed us to inspect the precipitation container and discover the URL to use for ingest. Now we can connect users of the Open Science Framework with the newly ingested data in Fedora using the Fedora OSF storage provider. I've already logged into the OSF and have pre-configured the Fedora storage provider to talk to my Fedora instance containing the precipitation dataset. Because the Fedora storage provider is under active development, I'm using a development version of the OSF platform for this demonstration. I've created an OSF project for the precipitation dataset. I've not filled in any of the aspects of the project, choosing to leave it empty so we can focus solely on the functionality offered by the storage provider. The storage provider allows you to mount any container in your Fedora repository. I've configured the storage provider to mount the precipitation container, so we won't see any of the other information in the repository. By now, the structure of the data in the files may be familiar. We are browsing the contents of the Fedora repository, and so we see the documentation for the data at the top level of the hierarchy. Let's open one of the files to satisfy that we can not only browse the structure of the repository content, but also download data. The Data Conservancy has produced tools that integrate with popular platforms which facilitate data curation, archiving, and access. The Data Conservancy packaging tool provides a mechanism
We can stop the video.
packaging data.
Yeah.
The package ingest services.
So the key message is that Fedora basically becomes a seamless part of OSF. And in some fundamental sense, you could imagine researchers literally dragging and dropping the content into the archive rather than this sort of, I'm done with my project, now I have a lot of work to do and I'm depositing it. It's a much more continuous, iterative type of process that we're envisioning and supporting. So with that, we have some resources that you may be available for you, and we'd be happy to take any questions if we have time. Thank you.
Would you like to join me in thanking the presenters first of all? Do we have any questions for our presenters?
Thank you very much for the presentations. Linda Newman, University of Cincinnati. I'd just like to be sure I kind of understand the connections we're talking about. It sounds as if at both Notre Dame and Johns Hopkins, you have built systems that allow the output of research projects in OSF to go directly into your local repositories. Is the integration that, David, you talked about with Fedora and OSF to support the same thing, or is there also a central Fedora storage layer now being incorporated into OSF, and does that change, if yes, does that change our plans for working with OSF for institutions and channeling content into our local repositories?
So thank you for that question, because we omitted to say one important aspect. The integration is for OSF for institutions. So once you have authenticated and we can verify you're a member of Johns Hopkins and Notre Dame, it is working with the local institutional repository. I don't know of plans to have a sort of Fedora central approach to this, but there are lots of other issues that would be raised if we went down that path.
Are there any other questions? No? Wonderful. Sorry? Yes? I should have had my joggers on.
Tom Morrell, Caltech. Really nice presentation. How are you thinking about really enriching the metadata at the level kind of within the Open Science Framework? How can you get more specific metadata about the projects and even getting to kind of domain-specific metadata?
Yeah, so I mentioned that the effort has been in multiple phases of things, and so what we have now being produced by the packaging tool that then gets fed into Fedora, it captures pretty much all of the metadata that is available within the OSF now. And in thinking about adding the preservation context, we've also tried not to assume that there wouldn't ever be any other metadata that we would want to add onto that. So the next phase of this is really to look closer at the kinds of metadata that are there. And within that framing of effort, we have something that is under planning being spooled up to further enhance the API and the interchange that happens with data coming in and out of the OSF to actually integrate much more closely natively with what's in Fedora, because you can think about kind of the way the OSF is structured. It has projects and it has components, and like a component may be a subsection for presentations, or maybe here's my data sets, et cetera. And it's really looking at also mapping the structure within the OSF alongside the structure that may be within Fedora as well. So to really have the things like data modeling have that more direct mapping between the two. So within that sense, the plan is to do an assessment of the metadata that's being collected and then work to add on anything that may enrich it.
And there is a capability to deposit JSON LD right now into OSF, not as metadata files, but as some sort of ancillary files that Fedora can then interpret. But Rick's correct that we'd like it to be a much more rich and robust process than that.